Here we want to evaluate the indefinite integral, and then once we do that, we want to illustrate and check the answer is reasonable by graphing both the function and its antiderivative. So let's first go ahead and evaluate this integral. So the first thing we're going to do is we're going to rewrite this as the integral of tangent theta squared times secant theta squared d theta. Okay, and so now what we want to do is then take our u substitution. So our u substitution, we're going to let u equal the tangent of theta. Okay, and the reason being is if we take the derivative with respect to theta, the derivative of the tangent of theta is equal to secant squared theta d theta, which is the same thing as secant theta squared d theta. Now we can go ahead and put in our substitution. So we have u squared times du. Now let's take the antiderivative. The antiderivative is u to the 2 plus 1 over 2 plus 1 plus c. So this becomes 3 in the denominator, and the reciprocal of 3 over 1 is 1/3. And that's u to the third power plus c. Okay, so now let's go ahead and plug in what we substituted for u, which is the tangent of theta. So that's the tangent of theta to the third power plus c. And therefore we end up getting 1/3 times the tangent theta cubed plus c. Okay, so therefore that is our result. And now what we want to do is we want to take a look at and illustrate what happens when you graph this function and the antiderivative. So down here you can see here that the blue represents the antiderivative and the red represents the function. So note that f is positive and f is increasing, and at x equals 0, f is equal to 0, and we can see that f has a horizontal tangent.